Hi everybody, it's Tiny Tom Logan back with another video for you, and today I'm going to be taking a look at the three most popular or from the largest companies, or however you want to put it, but ITX Z490 boards. So I've done a deep dive in there. We're going to talk about looking at the VRMs, VRM temperatures, overclocking. We got some interesting voltage fluctuations and differences with the boards as well, so we had a good look with that as well. And I just thought, with the smaller form factor, normally we would pick, a brand and then build the whole rig around it, but these are actually, amazingly for a change, quite close in price. So we go from 259 to this one up to 249 with this one. Now that's only a £40 difference. Now I know that's still £40 and a fair amount of money, but between the ITX boards, that's actually quite narrow because we could have had a much, much larger difference in the past. Admittedly, this isn't an all singing, all dancing kind of impact, crazy ITX one from Asus, but it does put them all in roughly the same sort of price bracket. So it's going to be quite an interesting one to see how they fare. So all three boards on the desk, and we are going to go through each one of them and skirt over the main features. But the one thing I will say is there is already a preview of the Strix and the Aorus live on the channel with a full write-up live on the website. You can also go and have a look at the website review for these four for more information and, more importantly, more benchmarking on the website as well, and I will put the link underneath as I always do, but you can always go over there and have a good look. Now the one that I've not really spent a lot of time with, because I had to ask MSI to send this one for me so that I could do this triple heading roundup, is the Unify. And it's actually the cheapest one of the bunch as well. So I'm going to start by having a look at this one, and then we'll skirt around the other ones a little bit quicker, because if you are interested, you can go and find the other videos. Now the MSI stand, while actually in reality being the best looking stand that I've got from any of the vendors, does kind of hide the bottom of the motherboard, and it's quite difficult to get it to stand up so that we can see it, but there isn't really a great deal going on the bottom of the board anyway, so it's not too much for us to worry about. The only thing to kind of really point out down here is the front panel header down here for the audio, and then you do have a USB 2 up here. The rest of it is at the top of the board, and we'll have a good look around. Now, most important thing to start with is the 8-pin up here in the normal kind of position that you would kind of find it. Then you do also get 3 fan headers up here, one of them being the CPU, one of them is CPU optional, and then the other one's a system fan one. There is an addressable RGB just here as well for you to keep an eye on, for those of you out there that might want to add the RGB, despite this being the Unify, which doesn't actually have any on the board whatsoever. You get 2 normal DIMM slots, ITX, kind of standard. Then you get your 24-pin here. You've got your couple of SATA ports, external USB-C, so 3.1 Gen 2. Then you have a USB 3.1 Gen 1 here, should you want it. I've shown you the USB 2. There is also another 2 SATA headers here for those of you that need it. Underneath this heatsink, which is the heatsink for the chipset, is also a M.2 slot. As it's Z490, it's only PCI Express 3. And there is another M.2 round the back of the board, should you need it. There is another addressable RGB header just there on the other side of the SATA. There is a 4-pin header here, which looks like it could be for normal RGB, but it's actually one of the front panel headers, just so that you don't get confused. Then the heatsink around the outside of the board is actually all metal, and there's a lot of it as well. Lots of cut and an intricate design when the camera decides it wants to focus again. Heatsink has lots of cuts, it's quite intricate, good for surface area. And then you can see the power array around that. I will go into more detail when we talk about the boards together, but it does have a direct 8-phase power configuration, and they're 90 amp each. And the MOSFETs are Intersil ISL 99390. Like I said, they're 90. And it's at this wonderful point that the camera batteries decided to die. But what I do point out here is DisplayPort, HDMI, then you've got some USB 2s, some USB 3.2 Gen 1s, and then some USB 3.2 Gen 2s, 2.5 gigabit Ethernet, and then my finger's waving over the breather port for the fan that's underneath. But there's no real like entry or exit points other than the little venting area that's there. So it has to kind of come out underneath the heat sinks. But it is there. And it's kind of difficult to remember what I was saying before, but I'm hoping now I'm going to talk to you about the Wi-Fi 6 and then the gold-plated audio out points. And then that's pretty much it. You'd never know, would you? Now, I have said that I've done a full preview about this board, and it is live on the channel. So if you want to go and take a much more in-depth look at it, you can go and see it over there. There's obviously more information on the website as well. Again, a little bit more limited on space, which is why Asus have kind of built up from the board with the daughter board. So the chipset heatsink is kind of underneath, but then you have the M.2 over the top. Then there's also, just down here, you can see that there's a fan header, and then you have an addressable RGB here. You also have a normal RGB at the top. Then you have a couple of fan headers right on the very top there, and a shielded 8-pin power. And then if you have a look, there's solid pins as well, which is something that they do shout about in the blurb that they send out to the press. Down the side, you can see that you've got your couple of USB connectors, 4 SATAs. It's the standard sort of stuff, just a different kind of layout. You can see the fan filter on the top here, and that's because they're, or mesh I should say, because there is a fan in there, but there's no kind of outlet for it per se. It kind of has to just come out around the bottoms. There is a heat pipe and a fairly meaty heat sink as well, and most of the VRMs are underneath this. There are 4 here, and then there's a further 6 up here. Now, with the VRMs, they are teamed, is what they say, and it was a bit difficult to kind of get information out of them about what exactly it was. Having a quick scout around for part numbers and stuff like that, they are Infineon TDA 21462s that they did use on the Maximus. Now, they're 60 amp each, and like I said, they're wired in teamed. Where there's 8 for the CPU, and then 2 for the other bits like the SoC, where they're teamed, that then makes me think that they're coming out of a 4-phase controller. But some of the stuff online that they talked about was, and it's on their website, actually says Doctomos. So I'm not sure whether it's a Doctomos controller, and to be fair, I have asked Asus about this as well. The information was just a little bit lacking, and it's something that moving forward it would actually be kind of handy for us to be able to have more information about that readily, just to be able to tell you guys. Sure, we could strip it all down and start having a look, but it would just kind of be nice if it was there. Anyway, you can see, because of the daughter board, they've spent a lot more time and effort on the audio. So you can see those Japanese capacitors there, gold capacitors. And also this has got a little bit of RGB on it, and there's a 4-pin header there. It's really easy to put an M.2 in there. You can actually see the thermal pad. Doesn't particularly make any difference. So you've got that there, and then if you have a look, you can see that there's another thermal pad underneath that hasn't been touched, but no M.2 around the back. So unlike the other two, what they've done is got them both on this side, and that's why they've kind of built up as well. So for those of you out there that are going to be having a couple of M.2 drivers and are a bit concerned about hiding it round the back of the board with limited access, a lot of cases might need you to pull the board out to be able to change it. That could be a good sway for you. Round the back, you can see that again we've got the DisplayPort and HDMI. There's more connections around this than there was with the MSI. Much less audio out though. But in reality, it's going to really depend on what you're after and, you know, what you're going to need to be plugging in. But you still do get your Wi-Fi. Moving on to the Aorus. This one is 26495, which I have said to you about before. Now, I have to admit, I have some very long-winded experience with Aorus ITX boards, and they always make me nervous because of the VRMs. But I'm going to say straight off the bat with this, they've got 8 digital 90 amp VRMs on this. And essentially, it's an ISL 69269. And actually, I do apologise. Look, I'm reading the wrong one. There you go. It's the 99390 90 amp, which is the same as the MSI. Also, if you have a look, they've gone to quite some effort in the machining for the VRM heatsink. So there's a lot of surface area there. You can also see that we have the heatsink here, but this part here is plastic. This part here was plastic. And straight off the bat, when I first saw this, again, it made me kind of nervous, but I'll talk to you more about the VRM stuff in a moment. You can see that we have the 8-pin over here, shielded, solid pins, ticks all the right boxes. Then you can see that we have a CPU fan header there. The other fan headers come on these little add-ons. Now, although they look messy like that, what it would allow you to do, if you really wanted to, is fold them up and over the board, poke them round, and you've not got the big normal PWM headers. And I think that's actually a relatively good way of tidying the board up. Down the side, we can see the 24-pin, 4 SATAs, same as the others, pair of USBs. You do get a normal RGB and an addressable RGB on this. One of the things I don't like is this. And what I would call a condiment cable. And I think that's not particularly acceptable in this kind of market now as well, because it's not a cheap board, and I don't think there's particularly any reason for it. If they had, when they were manufacturing it, put an extra bit, a single larger piece of heat shrink over the end of this, and then when they finished making it with those normal cables, slid it right over the top, put the heat shrink over it, it could have shrunk all that down. But now I only have white insulating tape at home at the moment. The black stuff's at the workshop. But something you can do with this is, it's quite a simple fix. Now white's going to show that we've done it, but what you could do with your black insulating tape. Now I know this isn't going to be perfect, but considering that this cable does the USB 2, I think most of you are probably going to want to use it. Now, it might take a couple of attempts to get it on and tight enough that it was going to cover the bulk of the cables up. But don't forget, if you were doing this on yours at home, I would suggest that you used black just to cover it up that little bit better. But obviously the white works relatively well for us showing you on the camera. Now, if I zoom right in, it isn't perfect. You can see a little bit more time maybe might be able to be spent doing it. But the problem is, again, when you start to pull it round, it does pull off, and there's nothing that you can do about this. The other option that you do have, if you use this at home, you can get something called liquid insulating tape. So you can put your black tape over the bulk of it, and then you can actually put a little bit black insulating tape in there. Or there are lots of other things like using a Sharpie pen, for example. Now I'm going to a little bit more in depth with that, because I genuinely do think that Gigabyte are very silly to have included that again, because it's something I've picked up in the past, but I'm trying to show you a way around it, because there's no way they are going to change that and then send everybody out new ones. So it's just something that we're going to have to make the best of. Another thing is pop these 2 screws off, pull that off. This is a dual M.2 heatsink and a chipset heatsink. So we can, the M.2 is underneath that, but it does have its own M.2 heatsink underneath as well. It's like a secondary one. You can just about see it there. but it does have another M.2 around the back. You can also see this brace as well, because a lot of the MOSFET stuff is hidden around the back of the board as well. Based on the information that we've been given, we can tell that we've got the Asus has got 8 60 amp phases. They're teamed, so that must mean that they're coming from a 4-phase controller. The other two have 8 phases direct from an 8-phase controller, and they're 90 amps as well. Now, I thought this would have made more of a difference with the actual VRM temps, but in reality, at stock at very least, the ROG did very well. And one of the things I will say right from the get-go as well is with the ROGs, they actually have a 2-phase kind of situation to the BIOS. So when you first boot up the board, it will ask if you want to press F1 or F3. F1 is going to give you the very strict, very close to the white paper power settings from Intel, but then you have the F3 one, which basically is the settings that we would expect a 10900K, for example, to perform at. So they give you the kind of choice. I tested all of this today with it on the F3, but calm down before you start thinking that I'm, making things unfair. These ones are pretty much in that mode anyway. So these come with a much stronger stock boost. When we go on to the overclocking though, and you start doing manual settings, the settings that I kind of put in and going in are turning off C states and adding extra power. It's pretty much going to the end of the earth to try and get the CPU to run as fast as it possibly can do. But we'll stay with VRMs because the graph can pop up, and I've told you about the parts that are in them for VRM control. So I was actually quite surprised in that the ITX one actually did kind of okay at stock, but it went completely the opposite way round when we went in and went mega overclock. You can also see that the MSI and the Gigabyte, clearly where they're running the same sort of stuff, didn't particularly matter what you threw at them. They didn't really get very hot. The Aorus one was quite strange in the fact that it seemed to run at the same temperature no matter whether I was running stock or overclocked, whereas the MSI kind of like mixed it about a little bit. Now, with the Asus, it was significantly warmer. Now, I will say that it was warmer than I was expecting. But we have a slight problem with the Asus one, and that is despite I looked on their own software, latest version of hardware info, actually trying to get a RPM reading for that fan was non-existent. There just wasn't anything there. There's also nothing there for me to be able to flick it on or off in the BIOS or anything like that. So the VRM fan, they did say to me, did it spin? And it was like, well, I have no way of showing how fast it can spin, and you can't really see it. And then again, I couldn't necessarily hear it either. So the temperature on this could be high because the fan hasn't kicked in. But I would suggest that that's probably at the point that they normally kind of make them start to spin up around 60 degrees. I do also kind of need to say that 90 degrees for an ITX board with a manual overclock on a 10-core processor isn't that bad. And if any of these other two had been putting that out, I wouldn't have been concerned. But it's always been Asus's party piece to have really, really low VRMs. Would I run this board 24/7 with those kind of VRM temps? I don't particularly see a problem with it. I was running it in a 20-degree room. It might be something that those of you out there in hotter countries might want to keep more of an eye on. Something that I did find as well was when I was using hardware info with the version that I was using, it didn't appear to be there, but it was actually right down at the bottom, buried within the GPU settings, which is kind of weird. It was a weird layout issue. I tried resetting the layout settings and everything with hardware info. If you're familiar with it, you can move stuff around. But I reset it so it was at default, and it always kind of popped up right at the very bottom. So the temps are there, which was nice. Some of the boards like this, they don't actually show them to us. But the VRM temps were not in their own software at all, which was another thing that made me a little bit uncomfortable, because with something like this, it's going to be something I'm definitely going to want to keep an eye on. Right, so a little bit warmer with a manual overclock. Could have been the fan, don't particularly know. We're going to kind of park that over there now. These two with the 90 amp, 8 channels were absolutely fine. The heat sinks did really well. I didn't have to add, well, I didn't add for any of them, any manual kind of fan cooling or anything on the top. Because it's a 10900K, what I do use is a H150i in the top of the case, because I actually tested these in a larger case like I have done all the other motherboards, so it was slightly more fair. So you could say that was a fair amount of airflow going over the top, and that might be something that you want to keep an eye on at home. But the thought of you having a 10900K with a poorly airflowed case, I think you'd be more sensible enough to know that you're going to need to make some changes. Something else that I did notice though, which didn't particularly sit very well with me when I first noticed it, and it's also been the reason why this video has been so delayed, was I used 3600 megahertz memory. Now I did try it with both G-Skill 3600 and some Corsair 3600 just to kind of make things a little bit more fair. And that was, I noticed on the Asus that the system agent voltage on auto with just XMP enabled was really high, which was 1.5 volts. Now, with the screenshot that's up, you can see that's auto. Then I put 1.5 in manually and you can see it's gone red. Then I turned it down a little bit and you can see it went purple, and it actually goes yellow at 1.15. And at 1.14 was the moment that it went white, and randomly it was perfectly stable when set to that. Now this is something I actually have to, there's a lot of information that I need to offload here, so I will try and be as clear and concise as I possibly can do. At stock, the Asus CPU temps were actually considerably higher than the other two, and it was one of the reasons why I always do a thermal run right at the very start. I use the latest Prime 95 and I turn AVX off, and then I use the very top one, which is not the most heat, but it's fairly high heat loading. And the reason why I turn AVX off is because it ignites another part in the processor, and it then basically makes everything run really high. Or at auto, a lot of the boards will down clock them a little bit more as well. So I don't do that because it's actually, it's just the way I've always done it, and it's the way I'll stay to do it. So with this, I was getting fairly warm temps, and then that led me to dig in. So I noticed that the system agent was at 1.5 and the VCC IO was also at 1.35. So I then went into the BIOS, started turning it down, cranked it down. I actually ended up knocking, give or take, 15 degrees off of the CPU temps on this board just by that. And it was still stable at 1.14, and I ended up getting it stable at 1 volt dead. So, and I actually started with testing with this board, and then when I moved on to these, the Gigabyte was putting about 1.3 through, and then the MSI was putting about 1.25 through. So I ended up running them all at 1.1 volts. They were all perfectly stable, and one of the things I will say as well is the scores in Cinebench for the Asus, with it turned down, because the temperatures had dropped, the Cinebench scores, not by a massive amount, but a couple of percentage points up, it actually increased. Now, I do have to be very clear that I spoke to Intel about it, and they say that the system agent voltage are actually within spec. But I said to Asus about it anyway, because I was a little bit concerned about the differences. Now, they did say to me it could be a CPU problem, but then I did raise with them that if it was a CPU problem, why was it different with the other two brands? And then the other thing to kind of keep in mind as well is, if it was a CPU issue, why was it actually then still stable at 1.1 volts when it was putting 1.5 through it normal? So that side of it didn't kind of sit with me very well. Where they said it might be a CPU problem, I then tried a 10900KF. It was a bit lower, but it was 1.49 volts. So if you have one of these boards at home, I'm not saying send it back. Have a look at the system agent voltage. You can download hardware info for free. You'll also be able to pick it up with Hardware Monitor. If and it's normally going to be based around your CPU speed. If you're using kind of like 3000 or 3200 megahertz, you'll probably be fine. But 3600 and above, it does seem to rage the system agent voltage when left on auto. Just go into the BIOS and turn it down. And if it's at 1.5, I would literally go down to 1.3, do a benchmark run, make sure everything's still running fine, then try 1.2, then maybe try 1.14, which is at the point that it goes from yellow to white. And in reality, for those of you at home, if you can get it down to the white and it's stable, I'd probably just leave it. But I would suggest that this is likely to be fixed in a BIOS revision. I did talk to Asus about it though, and they said they couldn't replicate it in the labs. And that was what led them to believe it might be my CPU. But then I tried another one and I was getting a similar kind of problem. So it is within Intel specs, and I have spent a lot of time talking about this, but that is because I spent a lot of time testing it, and I spent a lot of time waiting for replies, which took forever. So it definitely got brought up. So the most important thing is, at stock or with a mild overclock, you will drop your temperatures if you do that. Now, if you're now thinking that the VRM temps are hot because of that, when I was doing the overclock, I'd already manually set those volts, because I do stock first, then we go to the overclock. So those volts were all still in play at that point. If I had left the system agent on auto, then I wouldn't have actually passed the CPU thermal tests with this one. And for the overclock, they all did 5.2 all cores at around 1.3 volts. These two were 1.3 volts in the BIOS, and then with the load line calibration set as close as it possibly could do to give me 1.3 volts at load. You do have to kind of mess around with them all a little bit, because with load line calibration, the way I utilise it is if I've set 1.3 volts, that's what I want. I don't want any drop, and I don't want too much of a boost. The Asus actually needed around 1.33 volts to keep the 5.2 in play. So I actually do think that this just needs a BIOS revision, and I think the engineers will probably sort it out relatively quickly. It's about a month old now, so I think what's happened is they've done this and then they swiftly moved on to sort some of the B550 stuff out, and I just think that it's literally the first update that they put on the website. I think it was 0602. I should have written it down in my notes, but I didn't. So keep an eye on it. If you do have this board and you're running a 10900K, look at your system agent volts. Asus could be right. It could just be a weird glitch with my CPUs, or it could be a weird glitch with the board. But information is key in these times. So if you are running a high system agent voltage, you've already heard 3600 megahertz memory. I managed to get mine running at a volt, but if you can get yours running at 1.14, I would suggest stick fine with it, and then you've got a little bit of headroom for any possible degradation with your CPU or any other parts on the board as times move on. Right, so now we are going to go into performance, and I'm going to start with Blender because I like Blender, and I also like Blender because we use our own custom render for it, and there's 4 million polygons in this, and we do a 1080 version and we do a full 4K beast mode version, and the numbers in the graph are actually minutes and seconds. So you can see that the Aorus manual overclock has actually done really well, but you can also see the other kind of thing to pull out of this is that the ROG at the bottom with that F3 mode enabled, which is the thing that I need to kind of like stress the most, because I specifically run the F3 to make sure that it was running as quick as it could go. And I did take a few results between the two. So if I had an F3 and I had an F1, and the F1 actually did run worse than this, which is something it's the other thing I can't stress enough. I was actually kind of surprised about the stock on the ROG sitting at the bottom of the graph. But maybe that means that they need to kind of like give it a little bit more power and a little bit more boost kind of thing, because these were just run out of the box and they did incredibly well. And it was pretty surprising throughout. So when you go to Cinebench 20, the Aorus overclock did really, really well. And in reality, the Aorus and the MSI throughout the benchmarks, so I can show you some Cinebench 15, for example. And there's a lot more on the website as well. That's the other thing I do need to stress, is there's a lot more other benchmarks and information and all that kind of stuff going on over there. For those of you that are interested to the point that you're thinking about buying it, you know, you can go over there. As you can see, I talk way too much about this kind of stuff anyway, so if I had another 10 graphs to show you, we'd be here for an hour. But the MSI and the Aorus were always fairly close together, but more often than not, the Aorus just pipped it, but by like a minuscule amount. Unless you're talking about the differences between stock, you're actually not going to notice a lot of difference between the board at all. The ROG, even with that F3, you know, maximum performance kind of mode, always did fall behind the other two, which was something again that I was quite surprised about. But also because I was quite surprised about it, it actually made me then, like I said, that was why I actually ended up going back. And like I said, I ended up running some of the F1 modes to make sure that the F1 and the F3 weren't the wrong way around. And the F1 made things run a little worse. The only thing that it did do in its favour, it kept the temperatures down. But it kept the temperatures down for like VRMs. But it does make me wonder whether they hadn't really trained that system agent voltage in. And the board was kind of like trying to keep the temps down based on the temps that they'd done before and not realising that system agent was too high, if you get my kind of thought process, because it's all kind of conjecture and us guessing with why this one may have fallen behind a little bit. In reality though, the BIOS on the Asus I do personally prefer. Yes, it's kind of familiar because every single one of the boards is kind of the same, but it was also, despite needing a little bit more volts, it was actually easier to get kind of playing nice, but it's just a shame that the performance was kind of a little bit off. And as I said before, some of the temperatures were a little bit skew-iff when you really kind of ramp things up. These two though, I'm genuinely going to say I think are the star of the show because of those VRMs. They're much more capable, and they are direct 8 phase as well, so that was kind of really nice. And you did see that the VRM temps were lower, you did see that the performance was kind of better as well, so it was making me kind of think that where the power delivery on these is so similar, with the overclocks and the stock results, they're actually fairly close. The MSI at stock was probably the weaker out of these two, but it was still better than the Asus. So there is a lot of information here, but the random one to come away from this is, if I was going to pick one out of these three to use at home, it probably would surprisingly be the Aorus. And that's a big statement from me personally, because I have slated the Auruses in the past, but they really have taken the shortfallings that they had with the VRMs in the past and really cranked it up. And they've got some, like I said, they had some really nice things, and then they had some really bad things as well. I definitely have to fix that condiment cable. But also, in the past, I will say that MSI have had issues with BIOSes, and like the performance might have been a bit lacking just because they needed to spend a little bit more time on the BIOS. And one of the things I can say is their BIOS and the way stuff works has come on in leaps and bounds over the last kind of 6 to 12 months. So whereas I'd aesthetically probably buy the ROG because you can buy a Strix graphics card and it's all going to look lovely, and there's a lot more kind of ecosystem going on with the Asus, I'd probably end up picking between the two. And the other thing that I will say, and I'm going to keep bringing it up, which is going to annoy them, but with the Asus fan software, if you do end up having to use it, the fan software is linked to the CPU socket temperature. So it looks like the CPU is actually running quite cool, but in reality, if you use something like hardware info, hardware monitor, the temps are significantly different between the two. And it means that the fan profile ramp up, you need to kind of be aware of that to make the most of it. So it's a little bit of a catch-22 situation with these because, like I said, the CPU temp on that was actually really hot, but if you use their own software, it looked kind of similar between these because the temperature wasn't from the CPU, but a little pinout on the back of the board. So it's a little bit of a weird one in that kind of reality as well. And it's something that, despite me actually liking the ROG coolers and the way that they work, the software side of it isn't jammed into the CPU side of it enough. And it's a bit of a, yeah, it's a bit of a shame. So it's a bit of a weird one. I will totally take that all on board. I will answer all your questions that I can do underneath. I know this has been an awful lot of information to come at you, but in reality, I spent an awful lot of time testing and then retesting these to try and get to the bottom of all the issues. The Asus do know about all the stuff that I said about this and have known for a couple of weeks as well, and I've not really got much more than what I've told you about today. But if you are an owner, genuinely, it's not necessarily anything to worry about. I would just keep an eye on that system agent voltage. If yours is high, turn it down. You probably will see that you're gonna, if you turn it down as much as I have, you're gonna see at least 10 degrees drop. So that is a really nice handy tip to take from this review if you manage to sit through the whole of it. And I just run a few benchmarks just to make sure that you're not running into any issues and that your CPU or your memory, which is more than likely what it would be, that your memory doesn't need a little bit more system agent voltage just to keep things in check. But that is it, my dear friends. Like I said, these two, I've spoken to you enough. I'm not going to go round and round in circles. I'm sorry this review took so long, but I did want to keep going back and checking and double checking and making sure everything was right. But it looks like even the little boards are getting 90 amp phases now. And I, for one, don't think that's a bad thing when you look at the temperatures that we had with these, despite the small form factor and the fact that the CPUs were 10 cores and guzzling the power. But for now at least, this is the tiniest one out, and I have plenty more to come for you because I am really, really fighting my way back. So keep an eye on the channel if you're a regular, and if you manage to get to the end of the video, then you can post in the comments about your internet cookie. TTL out. Love you, sis.